Hello, everyone, and welcome to another episode of OpenObservability Talks. I'm your host, Dotan Horvitz, and here at OpenObservability Talks, we talk about anything DevOps, observability, and open source. So, as I always say, may the open source be with you, especially this month. We're recording it in the month of May. And let's go straight to today's episode. A few months ago, back in February, we had OTel Unplugged community event in Brussels alongside FOSDEM in Europe. I came back, shared with all of you here on the show that month that we were heading towards graduation of OpenTelemetry, OTel. And now it finally happened. This month, May 2026, the CNCF's TOC, Technical Oversight Committee, approved moving OTel up the maturity ladder and into a graduated project status. What does that mean? I got this question quite a bit, and we'll discuss it on today's show. And the newest signal in OTel is, of course, continuous profiling. If you've followed the show, you've heard it quite sometimes here. So I'd like to revisit this new signal and see where it stands. We have big news there, reaching alpha, so we'll talk about this as well as eBPF profiling agent that's supposed to make it much easier for everyone, essentially, that's trying to adopt open profiling. My guest today is Israel Ogbole. He's a member of the Profiling SIG, Special Interest Group, and is on the team working on the eBPF profiler. Hey, Israel, welcome to the show.
Thank you. It's an honor to be here.
Thank you. Yeah, you said that you've been following the show, so thanks for all the feedback about that. And really excited to finally have you here with this important topic. You're joining us from the UK, right?
Yes, I am. I'm based in Reading. I live in the UK. So if you come around, just hit me up.
Yeah, amazing. Yeah. So maybe for the listeners who may know OpenTelemetry but not your specific work, what's your path? You have an interesting path into observability.
Oh, I do indeed. So I used to work for a small company called Yammer. We got acquired into Microsoft, and all of my DIY solutions, monitoring observability solutions, just didn't work and scale at that level. And that was when, at the time, I brought in New Relic to Microsoft, and we wrote it everywhere. It was like walking into a dark room and turning the lights on. It changed my life. So at the time, it was called monitoring, like APM solution, not observability as it's called today. But yeah, that gave me a trajectory which I am still on today. So I went on to work for AppDynamics. After that, I got again acquired into Cisco, and then went on to work for Elastic after that, where I then focused squarely on the eBPF CPU profiler. And then we eventually grew the market, grew the product heavily. Also then went ahead and led the donation to the OpenTelemetry. And that was a big thing to do, by the way. So after leading the donation to OpenTelemetry, it was very much like, okay, what's now next for us to do as an individual, as a person. So we looked into the market, we saw that GPUs are becoming a big thing in the market. So we decided to put the same spin that we did on the eBPF CPU profiler to GPUs as well. So at Zimtrace, I started Zimtrace with Joe. Joe is also one of the big brains behind the eBPF CPU profiler. We then decided to apply the same concept to GPU profiling as well. And that's what we do at Zimtrace today.
Yeah, so that's quite a journey, and we'll probably be touching in many of these on today. But let's start with the big news. We talked about the big news this month. Marks a major milestone for the cloud native and observability ecosystem. OpenTelemetry officially became a CNCF graduated project. That's for the audience who doesn't know, that's the CNCF's highest maturity level, reserved for projects that demonstrate not just technical success, but also governance maturity, ecosystem adoption, vendor neutrality, security practices, long-term sustainability. So many people ask me what it means, and it's very important because there is a different notion of stability. So stability is like, GA or RC, these notions that we have in regular software. So the equivalents are the the software resilience, let's call it, which is the stability status of the different project, or in a project such as OpenTelemetry, each component has its own level of stability. Here we're talking about the graduation looks at it as in the open source sense. So obviously the technical maturity is an element, but also many other aspects. And in the case of OpenTelemetry, for those who don't remember, it's evolved from a merger of Open Tracing and Open Census to other projects within CNCF. And today, I guess, into arguably the industry standard for telemetry collection and observability instrumentation. So I think this is the stamp by the CNCF's Technical Oversight Committee to say that. It's really exciting for me as a CNCF ambassador, as an OTEL activist. I think this reflects something bigger than just project maturity. It signals that open vendor-neutral observability has moved from an emerging idea into foundational cloud-native infrastructure. So I'm really excited about it, but I'm biased. So I'm curious, you've worked across several major eras of observability. You talked about it, like AppD to AppDynamics, Elasticsearch to OpenTelemetry. What feels to you fundamentally different about the current phase we're entering now?
Yeah, and I want to use this opportunity to address, I think, the enterprise buyers, those who are making strategic decisions. And the reason I say that is because most of them may not be in the everyday runs of OpenTelemetry. The engineers kind of have a good understanding of this. The way I like to describe the significance of this is that it's now an enterprise bet. It's a safe bet, if you see what I mean. It's a stable platform that organizations can actually strategically plan towards. It's no longer dependent on one vendor or two vendors. The graduation simply is a big step, like you said. There are level of stabilities. It's like climbing a mountain. And I feel like this milestone is like right at the top of the mountain. All right. So for any organization that is still sort of like in between thinking about, should I adopt OpenTelemetry or not? Like, I would want to say that this graduation is a big stamp from the entire community. And it's really a safe bet for enterprises to build the entire strategy on OpenTelemetry as a framework and as a protocol as well. And, also I want to also give many, many, many thanks to the many, many people who've contributed to this. It's a long journey. And in my little experience working, yeah, indeed, in my little experience working with the profiling SIG, there is a lot of man hours that go into this. And organizations also sponsor it, because most guys that work in SIGs they all have their day jobs, right? They all have the day jobs. So
people, especially the ones complaining on GitHub, but why aren't you responding to me? I have my day job. This I do on the extra time that I have.
Exactly. People forget that easily. They all have the day jobs, and it's taken a lot of man hours to make this possible. So I would want to congratulate everybody and thank everybody that has done this. It's a massive, massive, massive step in the right direction.
Yeah, I'll second that. And actually, again, I get this question a lot because of the confusion. What the maturity, like what does it mean, a graduated project? So I'm wondering, in your perspective, especially maybe one that tried to donate a closed source or a non-foundation-led project and make it part of OpenTelemetry. So you've seen the process and maybe the criteria that the CNCF is looking to in order to ensure that a project being donated isn't just a GitHub repo somewhere that will be moving from one org to the other, but rather the what comes with it in terms of the diversity of organizations involved, in terms of the documentation, the processes, and many other aspects that indicate the maturity. Can you give us what your understanding is? It doesn't have to be the formal definition of what it means, a graduated project, or what are the aspects that the CNCF's Technical Oversight Committee is looking at to ensure that this is really graduated?
Yeah, so looking at it from the experience that you alluded to, at least the eBPF profile that we went through, one word is rigor. Like, it's got to pass through extreme rigor, a lot of scrutiny, a lot of reviews to make sure that if you ever to put this in production, at least it's safe. All right. So there's a lot of rigor from that. So what it does mean for the everyday user who may not really be in the thick and thin of this is that before a project gets graduated to a CNCF project, it must have been deployed across a lot of production environments. Security point of view, there's a lot of experts that will review it to make sure that it is secure as well. And most importantly, and this can be easily ignored, most importantly to me is that it's no longer like a 1 or 2% baby. Right. It has a long-term implication. Like it's here to stay.
Yep.
You see what I mean? And that's what I meant earlier on by saying like enterprises and enterprise buyers can strategically plan around this now. It is here to stay. It's not a project that would, for example, just dissipate in the next 2 or 3 years. Right. So in order to get to that CNCF level and getting that stamp, all of these criteria must have been met.
Yeah, for sure. And I guess the other aspect is really the vendors. So I guess when this becomes mature and established, and we've seen the process also before the official graduation, vendors started changing their perspective. So I'm curious again. You've been on the vendor side, looking at this new kid on the block, OpenTelemetry back in the day, and fast forward for today. Where do you see vendors? How do they think about differentiation in an OpenTelemetry world? Do they still try to differentiate through telemetry collection, or is that layer become commoditized? I'm curious, where do you see the vendor view of OpenTelemetry today?
Like I think from a vendor point of view, yes, I've been in the block for a long time. Like the differentiation is not so much in the data collection anymore. And that also introduced some problem because the differentiation is not so much in the data collection anymore. It also means that there's a lot of noise that's being collected quite often. A lot of noise. So there's a balance there. But collecting this data, because in the past, for example, when I was at App Dynamics, it was really about who's got the best agent, the best Java agent, the best C++ agent to do this thing. But all of that is gone now. And most recently, the profile that we worked on was actually the best in the industry at the time. And then we also donated it to OpenTelemetry. So I would say across the spectrum, both metrics, logs, tracing, right, including profiles, I don't think that data collection is actually the holy grail anymore. It's really about how quickly can you help users to get to the answers that it seek. One of the way I describe this is the 5 minutes to dopamine. Like how soon can you hit your customers with that dopamine? Like how can they get 5 minutes to dopamine? Like that is the answer I'm looking for. And that is where vendors should at least should look to differentiate now. It's really not about how efficient are you collecting the data anymore. It's really not about, what sort of data that you collect, but it's more about how quickly can you give users answers to the questions that they desire. And then the other component, which it's like opening a big can of worm, is also cost. That is a big kind of one, but I don't want to go there. But from a user point of view, I would say getting or helping users to get answers quicker, get that dopamine hit quicker is really, really the area that everybody should be looking to differentiate with.
Yeah, fully agree. And we've discussed that a lot. By the way, about the noise, we had a long discussion about that with Joassi here on the show. He's also in the depth of this pain with his startup and with his activities around the OpenTelemetry. So definitely, we don't have the same curation of the data and the same capabilities to control the enrichment as we would if it's a proprietary agent.
Yeah.
But I think it encourages vendors to contribute to OTel some of these capabilities, just for them to enjoy that on their backends on the analytics side. As you said, this is where they differentiate. And if not, having your a build of the OTel collector where you add your own processes with your own intelligence, but as pluggable processes on top of the open source, makes it a way to extend with your own wisdom and your own IP on top of the open source. So I think this was also the architecture behind the collector in the first place.
That's right.
And you mentioned the profiling. So really, I want to maybe spend a bit of time about this one, because profiling is, I guess, the new kid in the observability signals. Or on the signals, again, there are lots of other things happening. But while logs tracing and metrics have been around, like this is the newer one, and I've been covering it for years. I just told you just before the recording, I think even around 5 years ago, I already had an episode here on the show back in 2021 to share my belief that profiling is the next observability signal that will become mainstream. And many engineers back then, by the way, dismissed what I said, and there were very few that actually used it in production back in the day. Yeah. But again, that was 5 years, that's 2021. Fast forward for today, we're in a whole different place. I guess the biggest news from the OTel, beyond just being part of it, is that a couple of months ago, back in March 2026, it reached alpha. And I want to hear from you. But so essentially, I'd like to hear like what alpha means. What's the status today, 2026, and maybe how broad is the adoption of continuous profiling compared to logs, metrics, and traces, for example?
Yeah, so I would say from an adoption point of view, I think it's still a little bit behind when you compare it to metrics and tracing. And it comes back to the original problem that profiling had, just like you alluded to with what you did 5 years ago, and nobody believed it, that it was going to be anything serious. Profiling in general has been around for a long, long time, but it's traditionally hard to use, and people always use it on demand, never continuously, and there's a lot of reasons for that. For the first one, perhaps, will be the overhead it adds to the entire system. Traditional profilers can add anywhere from 40x overhead, for example. Oh, wow. You don't want to do that in production, for example. And then there are language-specific profilers as well. So you got to be like an expert in order to really understand the data that profiling gives. If I compare it to metrics, high CPU utilization shows me, everybody understands that. But when I put in a flame graph, in front of you, you're like, oh, what the heck am I looking at? So there's that level of, barrier that is also there for profiling as well. Until when I was working at AppDynamics, I have seen many times where we see production issues using distributed tracing, using metrics, and we just have no idea what is causing this. All we saw was just symptoms. We got high CPU utilization, for example, or then what we do, for example, go into the logs to try to find the data in the logs. If it's not there, you just don't know what caused it. The only option you have is maybe add additional instrumentation and then rerun again. And then maybe out of luck, you might be able to reproduce a problem. Now, profiling takes away all of those, especially continuous profiling. And that was why when I saw the optimized cloud team build profiler, I was AppD when I saw it, based on all the experiences I had at Microsoft, at AppDynamics, and I was like, that is the future. That is what we need. I spoke to Thomas at the time. I was going to join the team. And then Elastic acquired them. And I still joined after the acquisition anyway, because I so much believe.
That's the optimized startup that got acquired by Elastic for doing squarely profiling.
Profiling using eBPF. The guys did amazing work with it. And I so much believe in the technology. And the reason I believe in it, even till this very day, is because of what I just described to you. It's not enough to look at metrics and say, oh, there's high memory utilization. Or you look at even in distributed tracing, for example. I could look at trace and I know, okay, that span is slow and that trace is slow. But tell me exactly what was running on the box at the time. What is the line of code? Yeah. That is what profiling gives to you. The way I like to describe it is like if I give an example, maybe John, for example, John goes to the hospital, and then the nurses will look at John and say, "Hey, oh, John, you got a headache." All right, they will try to ask John certain questions. How did you come about this headache? Are you drinking enough water? Did you hit your head on something? All of those questions is more like trying to trace the cause of John's illness. They might also take John's temperature. Think about that, like, taking metrics, for
Yeah.
example, taking the temperature, but if they can't find any of the problems, or if they can't find the root cause of John's problem, what they would then do is go take an MRI scan or take an X-ray to look into the internals of the system. So, and that is exactly what profiling does. It looks deep into the internals of the system to let you know the exact lines of code that is executed on the machine. And then by doing that, you can easily pinpoint where the inefficiencies lie. And that's what we're also doing with Zimtrace. Like, we're also applying the same concept to GPUs as well. We trace from the CPU down to the GPU, and then that users know where inefficiencies lie. Now, going back to your original question, the reason I decided to give a bit of context is because most people just don't grab the power of profiling. And I wish engineers can use it more often. But yes, it's now graduated into public alpha. And this has a lot of significance, the protocol, because we've been working on this now for about 4 years. We donated the eBPF CPU profiler about 2 years ago. By June, it's in a few weeks, it'll be 2 years. So it's a significant milestone for the community. And what it does really mean is that the signal is becoming stable. And organization can actually take some bet now and run it in some small production workload, if you like, and see how it goes. You can actually start building tooling around the eBPF CPU profiler by the OpenTelemetry going forward. And a lot of credit to Elastic for doing this. Like, not many organizations will do that. And for me, I just give them a lot of credit and for enabling me and the entire team to be part of this donation.
So does the status of alpha come with certain guarantees? Is there like something more concrete that people can say beyond the title? What does it mean to the simple end user, as you said, that is debating whether to adopt or not? They have guarantees that they have now that they didn't have before.
Oh, yeah.
API stability, dependency. Can you tell us a bit more about what it means?
Yeah, so again, it's very simple. Prior to being alpha, the protocol can just change. It was not versioned because of that. Like, it changes. There's a lot of changes that goes into it. That may not necessarily be planned, for example. But going forward, you have a higher level of stability. It's not like fully stable yet. It's still alpha, but there's a lot better stability. And from now going forward, if it changes, will now be properly versioned as well. So you can have efficient backward compatibility, for example, without breaking anything that you may have built around this. So that, in its simplest form, that's what it really means. That it's much, much more stable than what it is. And it also means for the end user too that we've figured it out. It's taken a long time, but we figured out the direction now. And going forward, it's really about building on top of it and getting more community awareness as we move towards a more stable version of the protocol.
Nice. And amongst the companies that you do see adopting profiling today, just curious, do you see specific types of companies or specific tech stack or use cases where profiling lends itself better or I guess gets adopted more?
Yes, so it does. It does require, there's still that level of profiling not still being very well known. So for organizations, I wouldn't make it specific to specific organizations. I think it's more specific to the individuals within those organizations. Because if they have done some level of optimization, level of troubleshooting in the past, when they see profiling, it's just like, yep, I need that.
Performance engineers of sorts,
Performance engineers of some sort.
Yeah.
And mostly with security guys as well. They love the level of details that come in, right? But yes, we've seen adoption, at least in my time at Elastic, in my time now at Zimtrace. We've seen adoption across big AI labs. We've seen adoption across banks, as well. We see that adoption across even the big telcos as well. They are gradually adopting profiling as a signal as well right now. And the value that I try to paint around it is that it works better together. When you have metrics, give users the ability to drill down from that metric to the corresponding profiles. This is the very first thing we did in Impress, by the way. If you have tracing, for example, still give users the ability to correlate that distributed tracing to profiling. Yeah, it works way better when they all combine together, in my opinion.
Yeah, which is, I guess, the strong point for OTel. The fact that
Correct.
when it's compared, like I don't know, the logs capabilities of OTel versus some other logging mechanism or others, you miss. And I see lots of people doing this comparison, or companies that don't understand. They miss a lot of the extra benefit when you actually zoom out and look at it as part of the other signals. Because yes, you've grown to look at the signals segregated. So you have your logs backend and the tool stack, and you have your metrics and so on. And then they compare it based on these silos. And when I enter these rooms and they pull me into these discussions, I tell them, stop, your framing is wrong. I know that you've grown used to looking at siloed, but now it's no longer mandated because you have OTel. So zoom out, break the silos, and now what if you can actually have all three and start correlating between them, and then now compare, because the comparison is like crippled by the fact that you take away all the other signals and look at it only through the prism of a single lens. So I definitely agree with you, and it was really exciting when OTel profiling really became the fourth signal. I covered it here on the show with members of the profiling SIG. Founding members, and you're also a member of the profiling SIG. So maybe it's for those who are not familiar to learn a bit about the signal and what's the lessons. What lessons did profiling effort learn from OpenTelemetry's earlier experiences, standardizing logs, metrics, traces? How did it help you in your journey?
Massively, because we had to get the folks that did a lot of the work on the other signals to also help with profiling. Because majority of the guys that came into the profiling SIG initially, I don't think a lot of us had experience with the OpenTelemetry ecosystem at all. You had Ryan from Grafana. I was me from Elastic, and many other folks from Elastic and Optimize as well, and some guys from Splunk, and one other chap from Datadog, right? So we didn't really have much experience with how OpenTelemetry works and the whole principles behind it. We more like donate the profiler. So getting into it was super helpful, and also getting some OTel governance to also be part of the SIG was actually also super helpful. But fundamentally, the very, very first thing was pretty much the signal or the protocol, to be specific. We had this long back and forth, a long discussion about, do we make the protocol a stateful protocol or a stateless protocol?
Do we take off the shelf pprof, or do we need to adjust
exactly, it? Exactly. Those were a lot of back and forth, and I can see an argument for both sides. Because we were a strong proponent for the stateful protocol coming from our background using eBPF approach. You can also see the strong evidence for the stateless protocol because it's just pretty much how most other signals work in the OpenTelemetry ecosystem. And once people shed more light on it, you can just see the reason why the stateless will work for most of the use cases as well. So again, that's just one little edge case, but there's a lot more edge cases that we didn't know how to do this, and got a lot of help from the community to actually guide us on the right path.
Yeah. And I'm curious, what again, for the audience who's less familiar with profiling, just to make it really concrete for the day-to-day, what becomes possible when profiles correlate directly with traces, metrics, logs, resource metadata? Can you paint even a concrete debugging workflow that wasn't realistically achievable before that?
Yeah, just going back to my earlier analogy of John, that is the thing that you got to think about. Like, if you look at metrics, if you look at distributed tracing, if you look at debugging, if you look at logs when you want to debug, if doing this in isolation doesn't help. The way profiling comes into the picture and the way it helps is really to give you deep information into what the code is actually executing at the time. The code you're looking at, the code that may have made your metric spike, what is it that was running on the machine at the time? That is what profiling does in a very, very simple manner. But the way we did it though is we start tracing the code from the user space. So think of Python or Java, and then trace into the native code, because literally most interpreted or native languages go through some sort of native, go through syscalls as well, and then goes into the kernel. All right. So by the time you give a user that high level flow from a code that's run on the user space down to the kernel, you get a full trace of it. So profiling is essentially taking a bunch of stack traces as the code executes. You then merge them together and then visualize them mostly as flame graph today. All right. So in terms of the implication, or in terms of if you were to troubleshoot an issue, just think very highly. If you're looking at a trace, right, and you see, oh, that trace is slow. The question is like, why is it slow? So when you look for the why answer, go for profiling. If you're looking for the what and when, metrics, logs, and tracings are perfect for them. Does that make sense?
Yeah, no, it's just again
Yeah.
to give. I thought you may have like a wow moment from one of your customers or even internally with your engineering. You said, "Whoa, when we turned this
Wow.
on, suddenly we hit this after
I see what you
struggling
mean.
in the dark for."
Oh, I see what you mean. Oh, I have a lot of those use cases. I wasn't sure if I should go into them. Yeah, so I have a lot of those use cases. It came down to one example that I was working with where this specific customer, they had a bunch of workloads running one of these big cloud providers. I wouldn't say which one. And then what they noticed was a specific process. It's a daemon process that it comes on, executes, and dies. Comes on, executes, and dies. Like nobody knows. So they have this intermittent slowness in a specific container, and it doesn't happen to all the containers. It just happens that this specific application was, executing some funny Linux code somewhere, but nobody could figure this out. And then once they deployed one of our solutions, they found the issue over time. And what you came up to was like this cloud provider actually have their own agent that comes on, collect the data. And when that happens, there's some conflict that happens as well that affects their own application, right? And not only that, this agent that's deployed by this cloud provider actually consumed about 10 to 15% of the entire CPU cycle. And guess who has to pay for that 10 to 15% of the CPU cycle? The customer. So there are two big wins from this story. Like it's just very fresh in my head. The two big wins is that they were able to find the bottleneck as to why that conflict occurs and why that intermittent performance issue keeps coming up in the application that they could not reproduce easily. Secondly, they collected this evidence, went back to this big cloud provider and asked for some money back. Right, because literally they were consuming about 10 to 15% of the CPU cycle, which they have to pay for.
That's a good example. I love it. I love it.
And the evidence is just
performance and cost together.
And cost, like it was just one of those moments where, like, yeah, this is pretty. Yeah.
No, it's nice. Yeah. And again, when executing it with eBPF, you mentioned going all the way from the user space to the kernel space and maybe lots of layers of frameworks in between Cisco or whatnot. And that's part of the strength of eBPF. eBPF doing, again, I covered it in other episodes. So whoever is new to that, do check out. I'll add the links on the show notes for deep dive. But essentially, eBPF allows you to run these bits of code in the kernel space with hooks to different events that happen in the system, so you can really go to the depth of things. But I want to hear from you, not how it works in general, but like, what does eBPF profiling see the traditional language agents typically miss?
Oh yeah. So traditionally, you'll be looking at, if you have a standard language agent, a very standard one, is you focus on the user space code, right? Majority of the time. I think the guys in async profile sort of like extending that a little bit to the kernel as well. But traditionally, standardly, you would just see the user space code. All right, what your code is executing, it is a. Now, when eBPF comes to the picture, oh, by the way, with that too, you still have to load some library, right? Traditionally, you have to load some library, and when you do that, you do sort of runtime instrumentation, and that would also add a bit of performance overhead as well. With eBPF, however, like, you don't touch the runtime, right? So the code will run traditionally just the way you wrote it. Like, nothing goes away and mess around with the runtime at all. All right, because eBPF runs in the kernel. So you sit in the kernel and get an idea, or get all of the, as long as it has a PID and it's trying to access a program or access a hardware, you intercept it from the kernel, and then you unwind the trace from there into the user space. So what this really means for users is that sometimes if you're just monitoring your own application, say your own Java application, your PHP application, for example, you profile that only in that context. The eBPF approach profiles the entire thing on the machine, so much so that because you just don't know where the inefficiencies lie, or you don't know where the problem lies. Just the first example I gave you, that is not specific to the user's own application as such, right? There's no way you could use a language profiler and find that sort of issue, right? So the eBPF approach takes a system-wide approach, whereas a language SDK profiler takes more like a myopic, specific runtime profiler approach, where you can just monitor what's running on that code, running in your application, and how you may have to call in the kernel as well. With eBPF approach, we trace everything from the kernel all the way to the user space, so you can filter to your specific process. You can also have the ability to actually see everything else in the system that may not be related to your application, but are also more offending than your core application. Yeah. So it's really about the blind spots. And honestly, when I saw this a few years ago, I saw the approach, is why I jumped on that train. I was like, this is the future of observability if done right, especially from an infrastructure point of view.
Yeah, and it's amazing to see the growth. Again, I've covered it on the show in general, not just profiling in general. eBPF. I think I presented the Parka project and the Pixie project and other projects, open source projects that took the eBPF approach to tackle different sides of observability. Folks from Grafana Labs that donated code base from Bela, what turned on to be the OBI. As part of the OpenTelemetry as well. By the way, another great example of a vendor that donates a project or a piece of code. So it's very interesting to see whether for metrics or for monitoring or for profiling, it's really powerful. And I guess in beyond the advantages that you said, it's important to say it eliminates the need for the code instrumentation that a lot of time is a barrier to entry to many engineers. And what comes with it, the recompilation or service restarts and all of that. There is a concern that keeps on coming every once and again, the promise of a low overhead. And this is something that I want to touch. And if you can help us understand, what does the low overhead actually mean operationally for engineers?
Oh, yeah. So this, by the way, is a big thing. Because the promise of continuous profiling is that you can run it in production.
Continuously.
Continuously. Yeah. So if that is not met, if you can't run this efficiently and have a super low overhead, then you will never make it into production, and it will never run continuously. So everything depends on it, really. And so being able to run, and that's what eBPF does, actually. Like, I believe that building profiles using eBPF is one of the best ways to achieve that. But it's not just about eBPF, in all honesty. It also comes down to whoever is writing this code to be able to make sure that you're doing the right symbolization properly. You are not overly consuming resources on the machine when it comes to CPU and memory. From our approach, from what we did back in the day when I was at Elastic, was pretty much like we were very, very careful, because the guys that built this profile, they're all like low-level security guys. When I say low-level, like they're closer to zeros and ones. The bare metal, the better for them. And they took performance extremely seriously. I remember we would run the benchmarks nearly every day, and we would analyze the data, and just to make sure that this stays under 1% CPU. Also ensures that this also stays under about 256 megabytes of memory. All right. So the significance of being able to run in production or run profiling in production continuously at low overhead is one of the things that eBPF unlocks for us as well. And even as Zimtrace as well, we're not just using eBPF anymore for profiling. We are also using that to collect metrics on the host as well. So instead of using, Prometheus, for example, and just exporting this data, collecting metrics as well using C groups, we find that is actually a lot more efficient as well, because you're not pulling proc every time. You're just sat there, collecting these metrics. So you see, even he adds, doing proc ADC, when we measured it, it consumes about 1 to 4% CPU, depending on, what the size of the compute is overall. But by not pulling proc at all and still collecting metrics using eBPF, we also found that it's almost free as well. So I guess the point I'm trying to make is that eBPF makes it possible so that you can run continuous profiling in production at extremely low overhead, because you are not messing around with your runtime. You're not requiring users to do any sort of instrumentation. And most recently, we also now using it in production to also collect metrics as well and do the correlation together.
Nice, nice.
Yeah.
You talked about the correlation. That's actually interesting. When you do it with the language-based agents, I guess it's pretty intuitive for any engineer to understand how you do the correlation, because you're in control. You're in the scope of the invoking method or function or whatnot, and you have the context, and you can put it as part of the baggage that comes with it, and so. When you go down to the kernel level, which is way beneath the high level, we talk about high level languages like Java and C# and whatnot, how do you actually map it back to the function entities, all these high level logical entities, to the extent that you can actually also afterwards correlate to the other signals and so on? Can you give us a glimpse on the art and science behind it?
High level, very high level, because we did this work. Joe, my co-founder, and I, when we were Elastic, we actually pioneered this as well for the Java agent. At a very, very high level, I think what we did there, again, there's a blog post that goes into detail there. You still have to do some work on the Java agent to teach it, in terms of how do you, because you can collect this data very independently, but you need to be able to merge those traces locally before sending them out. All right. So we had to do the work such that it's not out of the box, essentially. You can't just take any hotel SDK and do that for now, at least. There's a library that we built into it so that you teach the Java agent. We did this spec for the Java agent so that it listens to the profiler data, they send the information to a common file, you aggregate the data, and then send it out from there together. That's the most simplest format. That's the way we've achieved it for now, and it's yet to be extended to other languages. As far as I know, we haven't touched it in a while because we're not focusing on GPUs heavily. But essentially, to answer your question, it was pretty much that we taught the agent on the box how to collect the CPU profiling data, collect the Java agent data, and then merge them locally before sending the data out as a protocol.
Okay.
Yeah.
So there is, and it's important just for transparency and for clarity for the users. There is an element that needs to be loaded on the programming language side to make this merge from all these hooks that run in the kernel level and to augment that, right?
That's right. So it's not so much about the collection at this point, because the both agents can work independently.
Yeah.
It's really about how do you merge the data to say that span or a combination of spans correlates to that CPU core and to that process that you are instrumenting. All right. So once we did the filtering locally, we then merge the traces before sending the data out, essentially.
Yeah, and so when we talk about the continuous profiling agent in OTel, can you tell us? So you mentioned about Java, obviously a lot of effort. But what other runtimes and languages does it support today?
You mean the eBPF one?
Yes, the eBPF.
Oh, all the major languages actually, and that's one of the advantage of it as well. It's not language specific as such, and I say as such in quote because, but it supports Java, Python, Ruby, PHP, Perl, .NET. Now we recently added, like all the major languages out there, right? And the way it works, it's pretty much at a high level, you trace the code from the kernel. Right. Once you then unwind the trace, you then identify the signature of the code that is executing or that's trying to access the resource on the hardware. And then once you find the signature, then we apply a specific unwinder to that code. So you have a language unwinder inbuilt into language unwinders inbuilt into it. So if you see a Java code, then you apply the Java unwinder based on the signature, Python unwinder based on the signature. So it's also modular, which means is that you can essentially build your own unwinder and plug into it as well, should you wish to.
That's
Right.
like the piece that will then give you the real, like the exact line of
Line of
code in the
code.
source code, because obviously the source code looks different than what's actually executed in the kernel. So the mapping back to the source code, the literal function names and parameters that again they don't go all the way down literally to the kernel. They get into a more processed format and so on, right?
Correct. And I'll add to that a little bit because so you collect the data using that approach. However, it's still zeros and ones. For native language, you get a lot of XX0000, like unsymbolized frames.
Yeah.
All right. So what we did was, especially on the kernel side as well. So what we did back then, even as Mtrace as well, is to build a symbolization service. This would essentially crawl like things like the Linux distros or the public Linux distros and public all the public and well-known container-based images like the CUDA frameworks and CUDA libraries as well. We index all of them and store them in a symbolization service. So our service will then look up the zeros and ones or the XXX nonsense that comes from the kernel, and then convert that to the equivalent of the source code. So you get a line number, function name, etc. that comes with it. For interpreted code, that doesn't apply because the symbols live on memory. So the agent is able to, steal it from memory directly. But for native, you need to have additional ability to also do the symbolization as well. And
you have also interpret. So you have interpreted, you have native like C and so on, and then you have the ones that use like intermittent language like JVM and so on, right?
Exactly. Exactly. With all of those, I think the major difference is either native or interpreted code. And when it's native code, then you got to ask, is the symbol stripped or not stripped? And I think that's what you're getting to there. When the symbols is stripped, then it's even more complicated because we give users the ability to then upload the symbols, for example, as well to the backend. Yeah. But so it's really, and I'm glad you mentioned that because eBPF CPU or profiling code using eBPF is fantastic. It gives you a lot of depth. However, operating it at large enterprises can also come with some challenges that you may not have with an SDK approach. And one of the big challenges is symbolization, like you alluded to.
Yeah, no,
Yeah.
it's important for
Yeah.
engineers to take that on advice. That's for sure. And so maybe talking about this project, as you said, it's been there already as part of Hotel. I mean,
Mhm.
2 years, and it ran before that in Elastic for some time. So it came already pretty mature. But I'm curious. Fast forward for today, what's the current production readiness of the eBPF profile,
Oh,
Hotel eBPF profile?
many organizations are running this in production today. I mean, for one, I'm as interest. We know people running this in production. Back at Elastic, I know a lot of customers, and I mean telcos and big banks run it in production already. So it's genuinely battle tested before we open source it anyway. And I think after open sourcing it, we've also seen tremendous amount of contributors come on board, tremendous amount of folks who are now adopting it. And your friends at Grafana, they're running that. I don't know what their customers are running, but sometimes we run into them in the field, and folks tell us, yeah, we're running the eBPF CPU profiler from Grafana. I was like, yeah, great. So
Nice.
there are people who are running this widely in production today. And you can also tell too, based on the activities that we see in the repo, right? The contributors are coming on board. People from, I was seeing the other day, people from AWS, where you are, Amazon, people from IBM, Instana, right? So I see a lot of contributors coming on board. And looking at it 2 years ago, it gives me a lot of joy that this little thing that we had, this little thought. I remember going and writing the RFCs. I wrote the RFC, deleted it, wrote it again. A lot of debate went on. Well, that's another story for another day. But looking at it now to see how widely it's been adopted all over the world, it just makes me really proud and very thankful to the team that were behind this originally.
Yeah, for sure. And if you mentioned that, that's a good opportunity to reach out to our listeners want to try it out, and maybe also to chime in and get involved. Do you want to tell them where and how to get involved, about the Slack channel, about anything that you recommend for folks to chime in?
Yeah, so in the CNCF Slack channel, we have the profiling SIG uh, channel there. The CNCF workspace, we have the profiling channel there. That is the right place if you want to get involved with this quickly. Alternatively, also look at the repo. I think you can add a link to the repo as well. There's some
Yes, we'll add it
tutorials.
to the show notes for sure.
Yeah, those would be the two main areas to get involved in. And the more involvement you get into it, the better for the entire community. Especially if you're great at low level, you understand low level coding, you want to get into eBPF. It's one of the easiest way to start as well, especially with a project that's getting adoption on a day-to-day basis.
Yeah, for sure. So joining this call, and we'll add the links to the show notes, and you also have the episode that we zoomed in on specifically on the SIG. And yeah, go in, look at it, especially if you're performance engineers or this is something that you're familiar with. Definitely look into. Are you using like the tags to mark good first issues or some things like that to help folks who want to get their toes wet with this?
Oh, so what do you mean by that?
Like GitHub issues that you tag as a good first issue or something like that for
Um,
new users?
I'm not so sure, honestly,
Yeah, it's
about
okay.
that.
It's a very deep topic. In other repos,
Yeah.
around Hotel and others, we try to tag like for those who are trying. But anyway, really check out the repo, and the story usually is there.
Okay.
And I'm curious, is is there a place that you can say still, like honestly, if that eBPF still falls short compared to traditional instrumentation, that you'd say what the trade-offs would be or considerations for folks considering taking one way or the other?
Yeah, I would like it's majorly that it comes down to the permission that I think eBPF needs. Still to this very day, you still require some level of cap sysadmin to run it efficiently. So I think that the more people can, like the more the community and the eBPF community can help to, make cap BPF or one of those low, or one of those higher level permissions a bit better compared to the cap sysadmin, I think that would be better for the entire community. The reason I say that is because um, for most organizations, when they see eBPF and they require capsys admin, that is a thing they're like, oh, we don't want to run this. And compare that to the language SDK approach. Obviously, you don't need that, but it comes with the additional performance overhead that you may want to get from the SDK approach. So yeah, for me, that's the main concern. That's the main pushback that I see in the industry today. And there are ways around it, except they are workarounds. If you see what I mean, they are not like true solution to it just yet. So it really comes down to permission. If permissions can get better, not be so, not to require root, I think I would see more adoption of this as well.
Nice.
For some companies though, and I have to say too, just to create a balance, about 3 years or 4 years ago, that pushback used to be very, very high. But I'm also seeing a lot less pushback now because other eBPF projects are also becoming more well-known. Things like the Cilium project, for example. Like literally nearly every customer today, or every big enterprise customer, they have Cilium in Kubernetes etc. running. And when you just say, oh, this thing is like Cilium, you actually have eBPF running already, but you just don't know it. Then that kind of like makes them relax in a way, if you see what I mean.
Yeah.
Yes.
Cilium already made the battle with the security teams, and you're just piggybacking on their acknowledgement.
Exactly. And if anybody listening that is maybe on the vendor side, you're trying to push eBPF and people keep pushing back, just use a Cilium story and piggyback on it, and hopefully that would reduce the pushback a little. But to answer your question, the big difference right now is just the permissions that it requires, in my opinion. Other than that, performance-wise, visibility-wise, I'm all for it. I think it's the right approach.
Sounds good. So maybe we mentioned where to chime in on the project. Do you want to mention where people can follow you, reach out to you, and after the episode?
Yeah, I'm very, very active on LinkedIn. So find me on LinkedIn, Israel Ogbole. If you also go check out Zimtrace, I'm also there on the About Us page. You see everything that we do there. Yes, X, I'm not so active on X, but I still have a handle there. So look me up there, Israel Ogbole, and you also find me there as well.
Amazing. So Israel, thank you so much for joining me. That was a fascinating chat.
Thank you.
And it was a privilege to share with you these very, very big announcements, both OTel graduation and the profiling reaching the alpha finally. So you're the perfect person to share that with and to be here. So thank you so much for joining me to know this and to help clarify all these big news to the to audience out there that doesn't understand how this applies to them in particular. So thank you so much. Again, a lot of information. By the way, you mentioned also a blog that explains some of the things I don't remember during the chat. If you want to send that as well, happy to add that to the show notes as well. And to our audience, thank you, of course, to you as well for listening and to the episode. As always, all the episodes are available on your favorite podcast app or on YouTube. So follow us there, and also follow us on the social media. We're on Blue Sky, on LinkedIn, on X, Twitter, at OpenObserve. So you can check out there more details and links and follow up to the discussion. I'm Dotan Horvitz. Thank you very much for listening. See you on next month's episode. And until then, may the open source be with you.
Thank you.